Today we are going to learn about preparation of haloalkanes and haloarenes. Friends, as we know, there are many methodologies to prepare haloalkanes and haloarenes. Basically, they are prepared from the addition as well as substitution reactions. So first of all, we will discuss halogenation of alkanes by free radical substitution reaction. By direct halogenation of alkanes in diffuse sunlight or maybe 400 degrees Celsius or by the catalyst, we can do direct chlorination and bromination. Suppose methane is added with chlorine in presence of UV light, we will get chloromethane. If the chlorine is more, then we can get dichloromethane, trichloromethane, tetrachloromethane. Means all hydrogen is going to be substituted one by one. Chlorination beyond monochlorination may be suppressed taking alkane in excess. Means if you want to get only monochlorinated alkane, then we have to add excess alkane. It is important to note that iodoalkanes can be prepared only in the presence of oxidizing agent like HiO3, concentrated HNO3, HiO4, etc. Because Hi formed during iodination is a strong reducing agent and reduces the product into the reactant back. Means it is reversible reaction. Here, this chlorination and bromination occurred through free radical mechanism. Means two chlorine atom is forming its free radical by homolytic cleavage, and then that is called initiation process. Means this free radical mechanism having three steps: initiation, propagation, termination. In initiation, as I said, chlorine is forming 2Cl free radical which is going to be attack on the CH bond of alkane, and again CH bond of alkane is broken in the homolytic way, so it will form methyl or alkyl free radical. Now this methyl or alkyl free radical is attacking with chlorine or bromine free radical and forming the product. Next, CH bond also can be broken if your halogen is in excess. So this is the simple methodology to prepare haloalkanes from alkane. Fluorination cannot be done by this method because it is very exothermic and explosive process. So this is first reaction. Now let us go to the second. Second reaction already we have done in 11th grade. It is just addition of HX molecule in alkene. Alkene, we have two types of alkene. One is symmetric alkene, another one is asymmetric alkene. So right now we will just talk about asymmetric alkene. In asymmetric alkene, if we add HX type of molecule, then there are two possibilities. Why? Because in asymmetric alkene, there are two possibilities of breaking the pi bond, which we have studied as Markovnikov and anti-Markovnikov rule. Here, as per the screen, you can see the Markovnikov reaction. CH3CH double bond CH2 propene plus HBr will give 2 bromopropane or isopropyl bromide. So here, as per the Markovnikov rule, bromide is shifting to the carbon where there is less number of hydrogen, or in another way we can say it is having more substituted carbon. This is Markovnikov rule. But if we want to get 1 bromopropane, then we have to add peroxide in this reaction. So if we add the peroxide, then the reaction will occur through homolytic cleavage and we will get 1 bromopropane as a major product. Here, bromination is easy for this type of reaction, as easily we can do this reaction. there are total 4 types of reaction in which we can get halides from alcohol. So first type is addition of HX or HCl in ZnCl2. So this is simple nucleophilic substitution reaction as OH is nucleophile. Second is in addition of PX3, here we have added PBr3 in presence of alcohol, we are getting bromoethane. In this reaction 3 moles of alcohol is used, so we will get 3 moles of bromide. And the byproduct is H3PO3. Third is addition of SOCl2 in alcohol. Then the byproduct is SO2, HCl, and we will get chloroethane. The fourth one is addition of PCl5. It is the same process, but only the byproducts are different. So suppose if I am taking ethanol plus PCl5, I will get chloroethane plus POCl3 plus HCl. From all four reaction, the SOCl2 is easiest one. Why? Because it is forming SO2 gas and HCl gas, so the separation of byproducts are very easy. So these are the all 4 reactions from alcohols. Now there are few reactions which are known as halogen reaction, in which we have to learn 2 reactions, Finkelstein's and Swart reaction. So let us talk about Finkelstein first. Chloroethane, when we are adding NaI, we will get iodoethane. So here we have to remember that we can just get bigger molecular mass containing halide from the smaller mass containing haloalkanes. Like here we can get iodoalkane from chloroalkane. Vice versa is not possible, as the formed salt is more stable. Like here NaCl is more stable than NaI. That's why this reaction is occurring. That's why this reaction is known as Finkelstein reaction. So it is also known as halogen exchange. The second halogen exchange reaction is known as Swartz reaction. It is specifically for fluoride formation. So here again, if we add HgF2 in chloromethane, then we will get fluoromethane with HgCl2. So this is known as Swartz reaction. Next, we can also get halides from ether. In hot HI, if we add ether, then we will get 2 moles of alkyl iodide and water. So this reaction will also come in the ether chapter. Next is Hunsdiecker reaction, which is prepared from the silver salt of carboxylic acid. Here we have taken the example of silver ethanoate. We have added bromine in presence of CCl4 and we have done refluction. What is refluction? You have checked about the distillation process in which we are using condenser to get the distillate. But in reflux, the condenser is put upward, so the vapor is going up and it is coming back into the solution. So that is called reflux. So here very important observation is that you will get one less carbon containing halide. So here as we have added bromine, we got bromomethane and the byproduct is AgBr and CO2. This will also occur through free radical mechanism, and primary halides is much more produced compared to secondary and tertiary halides. This reaction is, as I told, used to reduce the length of carbon chain by 1 carbon, and only bromides are obtained in good yield, although chloride can also be prepared, but the yield is very low. Iodides can't be prepared because in this case esters are obtained in place of alkyl iodide. Means we are not getting the iodide, but we will get esters. So for iodide we are having another reaction which is known as Birnbaum-Simonini reaction. So here we have to just add iodine, and if we get iodine then we will get ester. So this is not the preparation of iodide, iodoalkane, but it is the preparation of ester. So that will come in the next topic. So from above all slides, what we can understand, just remember, haloalkanes can be prepared by silver salt of carboxylic acid, from alcohol, from alkene, from ether, from halide, from alkane. Silver salt of carboxylic acid reaction is known as Hunsdiecker. From alcohol we have used for reagents. Alkene we can go for Markovnikov or anti-Markovnikov addition reaction. In ether it is substitution reaction by adding HX. Halide, where we are having two reactions, Finkelstein and Schwarz, that is halogen exchange reaction. And in alkane, halogenation reaction. So these are all about the preparation of haloalkanes. Now let us go to the haloarenes. Haloarenes, very famous reaction which we have studied here in the 11th, that is chlorination or bromination of benzene by Lewis acid. So here electrophilic substitution reaction is occurred. Here, like suppose we are using Cl2, then we will use FeCl3 as a Lewis acid or as a catalyst, and if we go for Br2 we will use FeBr3. Sometimes AlCl3 or ArBr3 also used. So this is very simple halogenation of benzene. Next, we are having diazonium salt. What is diazonium salt? It is also known as benzene diazonium chloride. It is prepared by the diazotization reaction. Means in aniline, if we add sodium nitrite NaNO2 and HCl at 0 to 5 degrees Celsius, then a stable intermediate is formed which is known as benzene diazonium chloride. The formula is C6H5N2 plus Cl minus. This diazonium salt is very stable, and in this if we do various reaction we will get various halides. So here again few name reactions are there. Suppose we are going to add CuCl or CuBr, then the reaction is known as Sandmeyer reaction. So if we add CuCl we will get chlorobenzene. If we add CuBr we will get bromobenzene. To get iodobenzene we do not need any name reaction. We have to just add Ki and we will get iodobenzene. To get fluorobenzene, there is a specific name reaction known as Borodine-Hunsdiecker reaction, in which we will add HBF4 in benzene diazonium chloride. So we will get fluorobenzene. If instead of CuCl and CuBr, if we just use Cu metal and chlorine or bromine, then the same reaction is known as Gattermann reaction and the product will be the same. Similarly, Hunsdiecker reaction can also be used for getting bromobenzene from silver benzoate. And there is a one specific reaction for competitive exam, that is from benzene. If we add thallium complex, then we will get iodobenzene. So again, we have used three main reactants to prepare haloarenes. Number one is benzene, number two is benzene diazonium chloride, and number three is silver benzoate. So in this all reactions, we have to just remember few important name reactions for both haloalkanes and haloarenes preparation. Number one Finkelstein, number two Hunsdiecker, number three Schwarz, number four Sandmeyer, number 5 Gattermann, and number 6 Borodine-Hunsdiecker reaction. Finkelstein is halide exchange to get iodoalkane. Hunsdiecker, from silver salt we will get one less carbon containing haloalkanes. Schwarz specifically for fluoroalkanes. Sandmeyer from benzene diazonium chloride to get halobenzene, specifically chloro and bromobenzene. Gattermann, just a few catalysts are changed and we got chloro and bromobenzene, and Borodine-Hunsdiecker is specifically for fluorobenzene. So hope you understood all this reaction. I have added just alphabet which is eco-friendly alphabet, and please follow Gandhian philosophy because the future is very competitive as well as we have to be very simple. So please follow this alphabet in your life. Thank you. As well as this is my concept, Voice of the Earth. So I request all of you to follow all these 9 R's. I think you just know about 3 R's: reduce, recycle, and reuse. But nowadays there are 9 R's: rethink, refuse, reduce, reuse, refurbish or regift, repair, repurpose, recycle, and naturally the last point was rote. Thank you so much for listening.